parents, co-faculty, and to all other sectors from different areas of specific fields, good afternoon. Welcome to College of Computer Studies Foundation University Digital Expo 2021. As we live in this world, we always look for a difference that could lead into creation of something that could use to make our life easier and more meaningful. We can really see how our lives shifted from ordinary into an extraordinary. As of now, we're still fighting the pandemic that we are facing as of today. And this is not just the thing, but because of the innovations that humans created, could pandemic is not just the hindrance of doing something new. We made it possible to be possible by the using of technology as a media and a tool to get services like shopping, entertainment, banking, and even more on education. We can really see the difference from the previous past years um, towards us today. But what really the connection of the IoT, which we will going to discuss to this for today's afternoon, to this fast and ever changing world. So what is IoT? IoT is as simply as Internet of Things and derived from the Internet and the things. When we talk about Internet, it is as simply as the interconnected of nodes, which is a bunch of connection from different computers throughout the world. And when we talk about the things in an IoT, um, it could be a person with a heart monitor implant, a farm animal with a biochip transponder, an automobile that has a built-in sensor to alert the drivers when the tire pressure is low, or any physical object that we can embed a sensor that makes the things or object to think. In a much definition of IoT, it is described as the network of physical objects, which the things um, that are embedded with sensors, softwares, and other technologies for the purpose of connecting and exchanging data with other devices and the system over the network. IoT is a giant network of connected things, which includes people. Because of these things, we can create a connections or relationship between people to things, and things to things. Also, the Internet of Things is expanding at the rapid rate, and it's becoming increasingly important for professionals to understand what it is, how it works, and how to harness its power to improve businesses. So, why is it IoT is important? IoT has become one of the most important technologies of the 21st century. Now that we can connect every, everyday objects, kitchen appliances, cars, thermostat, baby monitors, to the internet via embedded devices, seamless connections is impossible between people, processes, and things. This is because of by means of the low cost computing and cloud, the big data, analytics, mobile technology, physical things can we share and collect that data with minimal human intervention. So what are the advantages and disadvantages of Internet of Things? As we go along with technologies behind IoT, we can see that there are advantages brings to this new world of technology on how we can deeply appreciate um, and utilize our technologies. We knew that Every new technology phases has a million of challenges in its initial phase. Internet of Things also possess some of these grave issues that need to be tackled well in order to utilize its fullest potential. While the idea of IoT has been in existence for a long time, a collection of recent advances in a number of different technologies has made practical. One of the advantages of IoT is the access to low cost, low power sensor technology. So the affordability and the reliability sensors are making IoT technology possible for more manufacturers. Second is the connectivity. A host of network protocols for the internet has made it easy to connect sensors to the cloud and to other things for efficient data transfer. Another advantages of IoT is the cloud computing platforms, which increase in the ability of cloud platforms enable both businesses and consumers to access the infrastructure they need to scale up without actually having to manage it all. Next is the machine learning and analytics. With advances of machine learning and analytics, along with access to various and a vast amount of data stored in the cloud, businesses can rather insight faster and more and easily. So the emergence of this applied technology continues to push the boundaries of IoT, and data produced by IoT also feeds these technologies. So lastly is the automation and control. So due to the physical object getting connected and controlled digitally, so that certainly with wireless infrastructure, there is a large amount of automation and control in the workings. So without human intervention, the machine are able to communicate with each other, leading to faster and timely output. Though IoT delivers an immersive set of benefits, it is also presents a significant set of challenges. So here's some of the list of the major issues which gives the disadvantages of the IoT. One is the security. So IoT creates an ecosystem of constantly connected devices communicating over the networks. So the system offers little control despite any security measures. So this leaves users exposed to various kinds of attacks. Another disadvantage or challenges that IoT faces is the privacy. So the sophistication of IoT provides substantial personal data in extreme detail without users' active participation. Next is the complexity. So some find IoT system complicated in terms of design, deployment, maintenance given their use of multiple technology and the large set of new enabling technologies. Next is the flexibility. So many are concerned about the flexibility of an IoT systems to integrate easily and with another. So they worry about finding themselves with several conflicting or lock system. Lastly is the compliance. So the IoT, like any other technologies in the realm of business, must also comply with regulations. So the complexity makes it issue to compliance systems incredibly challenging, with many considered standard software compliance is a battle. So with this, with the overview, the advantages of using the IoT, so how IoT works. So here is an example of a basic IoT system diagram, which most of the IoT systems are being mapped. So we can see here that there is categorized with a three group, which is from the things, the fog, and the clouds. So from the things, we can see that it has the sensors and the actuators and the communication protocol. So we can see here that these are commonly the device itself which we implant or embed on the devices that you wanted to be smart or to think or um, to monitor. Then the fog itself has this wireless and or a wired or a power line. So these are commonly the bridging pattern or the way for us as a communication device for the system of IoT. And the cloud um, lastly would be which is the internet itself, that consists of database for retrieving and storing the data, record um, recording by the sensors and analyze using the data analytics, which we can now see the changes and updates using the smartphone or a computer devices. So this is a very simple diagram of an IoT, or how the IoT works when implemented to a business or to a manufacturer, to agriculture or and etc. So this is here an example of an IoT system, which is get from the basic of a IoT system diagram. So this is a simple smart sprinkler system. Uh, so we can see that a sensor, which is a moisture sensor, will going to detect the level of moisture on the soil and feeds into your system, which is on your computer or on a cloud, which the system decide if it needs to water and for how long. And it also feeds the information from the online weather services, which also gives as a feeding of data for your system, whether to give a water to your plants or not, because it's going to be rain or sunny, or the like commonly the weather forecast of that day. So then it will going to go to your actuators. Then it will going to send us to your actuator, which tells to turn on the bulbs of the sprinkler and shower your plants. Okay, so what are the actuators? We already talk about actuators, sensors, communication devices, and cloud. So we're going to dig down on each of these topics in order for you to understand what are those words or keywords of this IoT. So actuators is a basic motor that can be used to move or control a mechanism or system based on a specific set of instruction. There are three types of actuators: electrical, hydraulic, and pneumatic. So for electrical, it's commonly powered by a motor that converts electrical energy into a mechanical operations, while hydraulic uses a fluid pressure to perform mechanical movement, and for the pneumatic uses compressed air to enable mechanical operations. So in other areas, an actuator can be responsible for transforming an electrical signal into a physical output. So this physical output could provide information to a user via LEDs or modify another devices or environment. So regardless on how the actuator causes the movement to be performed, the basic function of an actuator is to receive signal from the controller and based on that signal perform a set of actions. Now for the sensors. Sensors are the devices that can be used to measure a physical property by detecting some type of information from the physical world. So this information gathered from the sensor could be a light, moisture, motion, pressure, temperature, or any other environmental condition. So a sensor can be connected to a controller either directly or remotely. So sensors and controllers are usually connected by means of analog or digital circuits. For communication devices, network devices that connect to each other through a network. So communication across a network is carried on a medium. So a medium provides a physical channel over each of which the message travel from the source to the destination. So most of the IoT communication devices that we use are in network media types, which is whether it's um, a wired, a fiber optic, or a wireless. It could also be router, switches, hubs, servers, yeah, and also with your the end devices, which is computer, desktop computer, laptops, printer, IP phone, um, or wireless tablet. Now for the cloud, cloud services are services offered by a cloud providers that are hosted off-premise and available on demand. So cloud services providers uses data centers for their cloud services and cloud-based resources. So with the using of the cloud services, we can save, store, and analyze our data from the devices that we are putting or we are being monitoring from the IoT. So with these services, cloud consumers have the access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal managed effort. So because of the high availability and great resource scaling properties of the cloud services, since these services are great way um, to extend the functionality of an IoT system. So data processing and storage can be done in a cloud instead of the IoT devices. Um, so because of these services that are all hosted in a cloud, so data and the resources are always available on any devices in the system. So as long as the devices has the internet connectivity, so cloud services providers are also very serious about security, ensuring customer data and kept safe and secure. So here are some of the list of the cloud providers that gives services on the cloud. So we have Alibaba Cloud, Liquid Web, Microsoft Azure, Amazon Web Services, VMware, Salesforce, Oracle Cloud, and the Google Cloud Platform. So cloud services providers use data centers for their cloud services and cloud-based resources. To ensure the availability of the data services and resources providers often maintain space in several remote data centers. So cloud computing supports a variety of data management issue. So enable access to organization data anywhere and anytime. Streamlines of IT operations of an organizational and subscribing only to needed services. Uh, Eliminates or reduce the needs of one-site IT equipment, maintenance, and management. And lastly, reduce the costs for equipment, energy, physical platform, requirements, and personnel training needs. And it also enables the rapid responses to increase data volume requirements. So that's one of the common services that cloud gives to their consumers. So with all those informations, how could an IoT start, or how could we start to build an IoT system? So based on a simple IoT system, most of the systems uses actuators, sensors, communication devices, and cloud services. So now we're going to talk about what are the common technology that we could use to create a simple IoT project. So most of the actuator devices used as an actuator devices are servo motor, stepper motors, DC motors, relay, linear actuators, and solenoid bulb. So when we talk about a servo, commonly these are the small devices that incorporates a two-wire DC motor with a gear train and a potentiometer integrated inside on the servo motor. While a stepper motor are a DC motor that move in a discrete steps. So they can have a multiple coils that are organized in a group called phases. While direct current um, motors, or the DC motor itself, um, is the most common actuators used to electronic projects. So they are simple, cheap, and easy to use. While um, linear actuator is an actuator that creates motion in a straight line. So commonly, it's like a motor that has a mechanical itself. Um, so which gives a motion of a straight line. So in contrast to a circular motion or a conventional electric motor. So linear actuators are used in machine tools and industry machinery, while relay are used as an electrical operated switch. So relays are used to uses electromagnetic um, to a mechanical operated as a switch, while solenoid is a simply um, specially designed electromagnetic. So this is inexpensive, and their use is primarily limited to on and off applications such as latching, locking, and triggering. Then for the type of sensors, so in many cases, sensors are useful in a very important for the devices in order to fetch the data or to get the data. So the data can be real time, which includes the current temperature, pressure, or humidity. So it can be also sense the object and calculate the distance between them. So we have types of sensors: the alcohol sensor, ultrasonic sensor, which gives the distance, the IR sensor, LDR sensor or the light sensor, gas sensor, which feeds the oxygen level, um, the carbon dioxide level, and so on and so forth. Then we also have the gyroscope sensor, for the gravitational level, for and rain sensor, sense hat, photodiode, IR proximity sensor, and PIR sensor. So let's go with another devices that we use in order to create an IoT projects is by the using of microcontroller. So these are the computer that can be programmed to detect an event um, that has triggered by the sensor and then perform an action based on the event. So microcontrollers are a great platform for performing this task due to their miniature size and low power requirements. So MCU or microcontroller is a simple computer designed to build in a small form factor. So when paired with sensors and actuators, microcontrollers can be programmed and to act based on the triggers. So one of the very um, popular microcontrollers today is the using of Arduino. So Arduino boards are able to read inputs such as light on a sensor, a finger on a button, or a Twitter message. So um, they can then turn an input into an output, such as activating a motor, turning on an LED, publishing something online. So all of this is defined by the set of instructions programmed through the Arduino integrated development environment, or the IDE. So um, IDE, or the integrated development environment, is commonly um, a tool um, for you to program your devices or your microcontrollers. So this is a way you can give them your microcontroller the functions and a set of instructions. So Arduino software IDE contains a text editor for writing code, message area and text console, a toolbar with buttons for common functions and series of menus. So we also have the single board computer. So single board computer is a complete functioning computer in which the microprocessor, input and output functions, memory, and other features are all built in a single circuit board. So single board computer are quite similar with the computers that we commonly use, but this is more um, this is a small size computer, and it is energy efficient and has no and it is not powerful as a regular PC or computer. So there are many different brands of versions of the single board computer. We have the Raspberry Pi, Fine 64, Binglebone Black, and etc. So one of the most common single board computer is the Raspberry. Popular single board computer is the Raspberry Pi. So this is the one. This is in a part of the IoT system. This is commonly the processing and a communication device for our IoT systems. So here you can also give the instruction and processing capabilities for your IoT projects. Another tool or thing that we need to learn in building IoT is by learning a simple or at least small knowledge on electronics. So electronics is a field of study focused on control of electricity and physical components and circuit that help direct electrical energy. So because IoT is more on connecting things and um, which powering the electricity, powered by electricity. So we have also to think um, that these components are also electronic components. So the world of IoT is based on several technologies. So one of these is increasingly available is the low-cost electronic sensor. So wait. So yeah. So so basic because creating an IoT project needs um, to build when building an IoT systems, you have to think for because we're adding some sensors, electronic sensors, electronic actuators, electronic communication devices. Then basic knowledge of electronics is a must and should be able um, to know. Or if you don't really familiarize with electronics, then you could ask someone who are really good on electronics. Then how are you going to yeah, so the implementation and application. So commonly the Foundation University has already created an IoT system, which is the smart dormitory. So smart dormitory has this automated lights, which you can turn in on and off using mobile devices or a browser, and also a the air condition also can be controlled using your smartphone, and it has a RFID lock doors, which as a key to your lock doors. Then the school itself has this RFID turnstile as for the student to get inside the campus. So that's under with IoT projects or systems. So another implementation or applications of IoT is from a robotics factory in China. So there, this is a factory that uses all functioned by a robotics. So these are commonly created with robotic arms to create the devices like smartphone. So yeah, so it gives a precise and accuracy of creating those kind of devices by the using of the robots. It could also be used IoT systems. IoT could be also used for yeah. So the robot Yumi is suitable for working together with people. So these are devices that it has a like a maneuver which you can um, perform an action, and the robot could also mimic your action. So these are commonly used for a very various, for example, if there is a very highly contagious chemical, um, like very sensitive sensors or electronics that we don't wanted to mess around with those electronics. So yeah, so another thing is the automation control system. So we could IoT could also do the sorting and the processing of the goods that we are we bought on the store or a mall. So for example, this commonly under uses on a manufacturer as a automation control system and a smart city. So smart cities are this is also a IoT project or a IoT systems that gives the city to be smart um, because of the road that they have this like smart traffic lights, um, even on for the traffic management system, like for example, if the road has um, like yeah, so that like sa mga like what a smart city should be, like for example, the smart grid also could be under with the smart city, like using a solar panels, which you can monitor the electricity and the current consumption of the city. So like we could do a smart water, so smart lighting, so eliminate your city communities and campuses with secure, reliable lighting infrastructure. Transportation, um, for and also connect roadways to transmit systems to protect road users to ensure equitable access to efficient mobility. So one of example of a smart cities that doing right now is the Hamburg, Germany. So yeah. So another IoT solutions is using the power grid. So so smart grids interact with smart homes. So renewable energy resources, customers, operations, distribution, and like electric vehicles. So a smart grid brings the notion of many different individual homes, buildings, and smaller grids generating power not only for themselves but also giving energy back to the grid for other to use. So in this solution, we can efficiently utilize the power, the consumption, monitor, and control, and giving back to those in needs of these services. So manufacturers, electric vehicles are doing this smart grids. So with these innovations, we can see the digital transformation, which IoT um, merge physical and virtual worlds, creating smart environment. So this includes smart city, smart hospital, smart highways, and smart and also more on smart factories. So yeah. So now let's go with the industrial IoT. So industrial IoT is referred to as an application of an IoT technology in industrial settings, especially with respect to instrumentation and control of sensors and devices that engage cloud service technologies. So the following of the some are some of the common uses of industrial IoT: smart manufacturing, connected asset and preventive and predictive maintenance, smart power grids, smart cities, connected logistics, smart digital supply chains. So industrial IoT focuses on the use of cyber physical systems to monitor the physical factory processes and make database automated decisions. So while the physical systems are made the intelligent using IoT, and the real-time communication and cooperations both with each other and with humans is established by a wireless web. Industrial IoT brings in the concept of connected factory leads to a smart factory. So what are what industries can benefit from the IoT? So as what we talk, so commonly this is um, we can IoT could benefit it from a manufacturer. So manufacturing can gain the competitive advantage by using production line monitoring to enable proactive maintenance and on equipment. Automotive, so the benefits of applying IoT to production lines, sensors can detect implementing impending equipment failure in vehicles already on the road and can alert the driver with details and recommendation. So for it could also industries from transportation and logistics can benefit from IoT by fleets of cars, trucks, ships, and trains can carry inventory that can be rerouted based on the weather condition, vehicles availability, or drivers availability thanks to IoT sensors data. Then for the retail industry, so IoT applications allow retail companies to manage inventory, improve um, customer experience, optimize supply chains, and reduce operational cost. And for the public sector, so the benefit of IoT to the public sector and other services related environments are similarly wide ranging. Then lastly is the healthcare industry. So IoT monitoring provides multiple benefits to a healthcare industry. So by the doctors, nurses, and order lines often need to know the exact locations of the patient assistance assessed such as wheelchairs. So these are industries that will going to benefit for this IoT or Internet of Things systems. So what are the futures of the IoT and the career path? So the future of IoT is potentially to be limitless. So as many networks and IoT platforms involved to overcome these challenges through increased capacity and AI services provides the edge performance into an IT and web scale markets. So the advances to the internet will be the accelerated through increased network agility, integrated artificial intelligence, and the capacity to deploy, automate, and orchestrate and secure diverse use case at a hyper scale. So the future of IoT is limitless, um, and it's still ongoing to create more and more advanced technologies to the near future. So IoT Expert salary based on the location. So this is a chart illustrate the average salary of a major cities around the world. So IoT experts are in a high paid salary. So this is from um, the hire.com. So commonly from Austin, it ranges from 125,000 123 sorry from $60,000 up to $145,000 is the average for the IoT expert. So here are the careers for the IoT. So IoT developer. So IoT developers create an applications that allows devices to functions. So the role of the IoT developer is responsible for IoT is responsible for oversees the creations of software used to support specific IoT applications. Sorry. Another duties for a IoT developer may include using algorithms to analyze data, using software tools to manage large amount of data, and filtering out unnecessary data, and also that the system will not going to be overwhelmed. Then another careers for IT is the IoT architect. So it provides the comprehensive perspective to a company-wide strategy, and it has the responsibility of um, for the developing strategies surrounded with which IoT platforms, sensors, and actuator should be built, and it also which connected to those technologies should be used or developed, and how to best meet the potential client needs. So that's commonly the responsibility of an architect. Then for IoT embedded system designers, so these are IoT connected devices consist of sensors, microprocessors, and software that help run the system. So embedded system designers are responsible in creating an IoT system designing, in charge of creating device specific firmware using the Python, C++, and other programming languages. So designers work closely with the hardware involved as well. So necessity and with a deep knowledge of devices on which the framework is intended to work. Then lastly is the IoT solution engineers. So IoT networks can easily be customized to meet the range of needs, and solution of engineers are tasked with helping consumers find the solutions of their business challenges. So the IoT software solution engineers are responsible for um, work closely with customers to identify their needs, taking a hands-on approach to determine what types of sensors, wireless technologies, and other components should work best for them. And these engineers may suggest the use of off-the-shelf components or work with developers to create a customized system if needed. So that would be for all for this IoT topic or IoT discussion. So I hope you get something out from the IoT. Sorry for a very fast discussion because we're just only limited because of the limitation of time. And I hope you gain at least something or a quite small or small knowledge um, out from it. So yeah, so that's all. I hope all of you give the understand, or you have get the overview of how IoT works in this in today's generation. So thank you so much for joining to our Expo 2021. So I hope that you've learned something again out from my discussion. So thank you so much and goodbye.